Hi everybody. Today I make you a video presentation. And the title is Network Layer Internet Protocol. Introduction. Figure 20.1 show the communication between Alice and Bob at the network layer. This is the same scenario we used to show the communication at the application and the transport layer recently. Communication at the network layer. At the picture is a communication between Alice and Bob, where uh, where the network is responsible for choosing the route to send data using the IP address. So every time a router is sent, it must send data to the network in order to find the IP address of the next router or WAN service. From picture, Alice sends to router R2. At router R2 sends to network layer. Network layer is used to send to R4 or router R4. And router R4 is a national ISP. National ISP is Internet Network Service Provider. Internet Network Service Provider sends to service WAN. A service WAN sends to R5. Router R5 and sends to network. Network sends to R7. R7 router R7. Router R7 sends to network. And network is sent to WAN service. WAN service sent to uh, network. Network is sent to Bob. Okay, the next. Network layer service. Before discuss the network layer in the internet today, let's briefly discuss the network layer service that in general are expected from the network layer protocol. Packaging, encapsulation, thing, the payload and decap, adding ahead, fragmented at the source or the router along the path. Doing the service of a carrier at the postal office. The next, continue. Routing the packet from its source to the destination. Finding the best route among these possible router. A combination of network LANs and WANs and other done by running some routing protocol forwarding. The next forwarding process is router and forward doing value. Forward doing value have a AB. That AB is data from router. At the output interface is 12. 12 is send a packet out of interface 2. Defined as the action for the forwarding table. The destination market table, forwarding table, or routing table created by routing start together routing protocol, a piece of information in the packet header. The next is packet switching. From the discussion of routing and forwarding in the previous section, we infer that a kind of switching occurs at the network layer. A router, in fact, is a switch that creates a connection between an input port and an output port, or a set of output ports, just as an electrical switch connects the input to the output to let electricity flow. And they have circuit switching and packet switching. The next is continue. Datagram approach, connection list service, and vital circuit approach, connection oriented service. Have a setup phase, data transfer phase, and teardown phase. The next is connectionless packet switch network. As sender, have a 1, 2, 3, 4 is a data sent from network. Network sent to R1 or router 1. Data 1 sent to R4, R5 out of order receiver networks, but data 2, R1 sent to R2 and send R5 sent to receiver. Will get S packet having no relationship to any other packet. Delivery of packet. The switch router. The next is a virtual circuit packet switch network. At the network, sender and send data 1, 2, 3, 4 is a one-way. R1 send 1, 2, 3, 4 send to RT, and RT send to R4, but 1, 2, 3, 4 and at receiver. A vital connection should be set up first to define the path for the datagram. Alert source and destination address a flow level. A three-phase process, a connection-oriented service. Setup phase is a two auxiliary packet. Is a 1. The request packet. 2. The acknowledgement packet. Market entry is a 1 transfer and teardown phase. Transfer phase is between dash to phase, and teardown phase is deleting the corresponding entries, responding with a concatenation package. The next is network layer protocol. In this session, we show how the network layer is implemented in the TCP/IP protocol source. The protocol in the network layer have gone through several versions. In this session, we connected on the current version. The next is position of IP and other network layer protocol in TCP/IP protocol source. At the network layer is a help, IGMP, ICMP, IP, and ARP. At data link layer and physical layer have a underlayering, LAN or WAN technology. One main protocol and 3 auxiliary protocol. IPv4 packaging for forwarding, and delivery, post office, unreliable, and connection-less datagram protocol. Pair with a reliable transport layer protocol such as TCP. At the ICMP-v4, handling some error. ICMP multicasting, ARP mapping network layer address to ring layer address. The next is IPv4 datagram format. Packets used by the IP are called datagram. Figure at 4.24 show the IPv4 datagram format. Datagram is a variable length packet consisting of two parts, header and payload data. The header is sorry, a header is 20 to 60 bytes in length and contain information essential to routing and delivery. It is customary in TCP IP to show the header in 4-byte section. The next is IP datagram. IP datagram at header. At the is a payload. At header is a 70 to 60 byte. And header combination payload have a 22 approximate is a 60,000 byte. Okay, legend VR is a version number. HLEN is a header length. Byte is a 8-bit. VER used in 4-bit. And HLEN is a 4-bit. Combined is a 8-bit. Service type 8 bits. Combined is 16 bits. And total length bit is 16 bits. The next level is identification 16 bits. Flex 3 bit. Fragmentation offset 13 bits. And next level is time to write 8 bits. Protocol 8 bits. Header checksum at 16 bits. Source IP address use 32 bits and destination IP address use 32 bits. And the last level is option pass coding used to 0 to 40 bytes. Okay, the next is multiplexing and demultiplexing using the value of the protocol field. Some protocol value is ICMP01, IGMP02, TCP06, UDP17, and OSPF89. Multiplexing at the source, demultiplexing at the destination, at the port number at the transport layer. At transport layer have TCP and UDP. Add to payload. At the network have ICMP, IGMP, OSPF. Three mode is payload. payload call is a datagram. Okay, the next is IP datagram format. Continue. Have a fragmentation, maximum transfer unit, MTU, at 2 file related to fragmentation. The next, security of IPv4 datagram. Packet snatching to intercept an IP packet and to copy its packet encryption. The next, packet modification to modify the packet data integrity mechanism. IP snuffing to message as somebody else origin authentication mechanism. And the last is IPsec, IP security credit, a connection-oriented service, defining algorithm and key. The next is maximum transport unit, MTU. A datagram can travel to different networks. The format and size of the frame depend on the protocol. MTU maximum size of frame payload have a header payload IP datagram, and the next level is a header frame payload, header and frame. LAN is a 100 1500 byte. WAN large or smaller. Larger or smaller. IP datagram is approximate is 65,000 bytes. Dividing the datagram fragmented by the source host or any router in the past. Lesson by at the final destination, changing the value of 3 file flop and fragmentation offset at total length. The next is IP4 address. The identifier used in the IP layer of the TCP/IP protocol serves to identify the connection of S device to the internet is called the internet address or IP address, and IPv4 address is a 32-bit address that uniquely and universally define the connection of a host or a router to the internet. The IP address is the address of the connection, not the host or the router, because if the device is moved to another network, the IP address may be changed. Continue. Address space, the total number of addresses by the protocol. IPv4 is 32-bit. It's a 232 bits. N-bit. And the next is notation. Binary notation. Dotted decimal notation. Hexadecimal. Network programming. Hierarchy in address, telephone network, postal network, divided into only two parts, and a fixed length prefix, variable length prefix. The next is three different notation in IPv4 address have a binary. Binary is dotted decimal, and the last is hexadecimal. Then is heresy in address. Heresy in address have a 32 bit. In 32 bit, it have a prefix in n bit, and suffix is a 32 less and n bit. The next is IPv4 address continue. Classful addressing frequent prefix and file class address depletion, no more address. Sorry. Subnetting and supernetting to always address depletion. But this idea did not work. Divided into several subnetting combining several class C block. Supernetting. If a network in class is divided into 4 subnets, each subnet has a prefix on off and such bits equal to advantage of classful as addressing. Easily finding the class of the class address the prefix length. Next is occupation of the address space in classful addressing. Address space is a follow picture that A is a 50%, B is a 25%, C is a 12.5%, D is a 6.25%, and last E is a 6.25%. As the class A is a have 0 prefix and suffix, as the class B is a 10 prefix and suffix, class C is a sorry. Class B is a 10 prefix and suffix, and class C has a 110 prefix and suffix, and class D is a 1110 is a multi-class address. Class E is a 111 reverse for future use. Okay, class A and class A and prefix n equal to 8 bits. First byte is 0 to 100, 127. Class B have a prefix is n equal to 16 bit, and first byte is 128 to 191. And the class C is prefix is n equal to 24 bits. First byte is 192 to 273. At last, the prefix is not applicable. First bit is 224 to 239, and the last class E prefix is not applicable, and first byte is 240 to 255. Okay, the next is slash notation. CIDR. CIDR is a cashless interdomain routing. How to find the prefix length? The prefix length n is added to the address space by slash. The picture is a cashless interdomain routing. That is a byte and dot, byte and dot, byte and dot, byte and dot, and divider and prefix length equal. Example is IPv6 address format. This is a global prefix and any subnet, and this is interface ID. Okay, the next. Thank you, teacher. Thank you, everyone. Thank you.